Alright then, so I'm just getting the stream. It should go to my headphones, so if I get only call, then I will do it. Okay, so this is the January 2012 past paper. So I'll be going through each question after each other. This stream should be probably, well, the video should be about an hour, 30 minutes. So first question, an interrupt may occur during processing. State the purpose of an and give one state the purpose of an interrupt and give one example of a high priority interrupt. Okay, so the purpose of an interrupt is so that a process that is more urgent, that has a higher priority, can be performed. An example, a mouse cursor. Let's have a look. So, to alert the processor that a task needs to alert the processor that a task needs attention or request processing time. And an example you could have given was a power failure. Guidance. So you could have said causes a break in execution. So you're going to state the purpose of the interrupt, so to alert the processor that a task needs attention, and then you need to give an example, so power failure. Allow hardware failure or clock as example. So they didn't want mouse, since that isn't exactly that. Well, it is a high priority and all, but power failure is more of a higher priority. Alright then, so next question. Describe the use of a data structure while interrupts are being serviced. The use, so describe the use of data structure. Describe the use of a data structure. So give an example of the data structure that might be used to the interrupts, and then what happens when an interrupt occurs, maybe is that what it's after. So a stack, a jump instruction can happen. So a higher priority thing gets pushed up to this, or it might be a queue actually. It might be a queue instead. Let's have a look. So stack, last in first out, to store the contents of registers, return value to registers in order to resume processing. Oh, so this is what they wanted to describe the use. So describe a data structure that might be used. Then what happens with the so what data structure would they use while a interrupt is being done? So it's, you have a stat because it's last in first out. It's because you want to store the contents of the registers, then return after the interrupt is being processed. You return the values to the registers in order to resume the process that you were doing before. And that's 4 marks. So you can say stack, then to store. So it's just saying that bit. So they might accept you just saying last in first out. So explain how an interrupt is detected during the fetch execute cycle. So interrupt is detected. A command. What do you mean detected? Does that mean like a command has been sent? So like interrupt's been sent. So that's the, I don't get what's it meant to be. So explain how an interrupt is detected during the fetch execute cycle. So they might want you to say, explain. So what happens? How does the processor know about an interrupt? So interrupt sends a signal to the processor saying that something needs to have its attention. Yeah, I'm going to use the arrow key. So interrupt register, of course, because that's another type. So interrupt register is checked when each cycle is complete. So at the end of each cycle, each probably machine cycle, the interrupt register is checked to see if it has any value. It then compares priorities of the current tasks with the interrupt. So say if currently a higher priority task is being done, then the interrupt, if it's a low priority one, it won't happen, or it will be delayed a bit more. So by comparing priorities of the current task with the interrupt register, so that's it. So the next question, after most interrupts, normal processing is resumed. Give one example of an interrupt after processing is resumed. A printer buffer. So when a printer when the buffer for the printer needs to be refilled, it sends the interrupt to say, I need more data. So let's have a look. So print it out of paper, or accept any valid example. So printer, you could have said printer's buffer needs to be filled. Printer out of paper. So yeah, that's because on the printer it's set before you print. It would check to see if there's any paper in a tray. If there's not any paper in the tray, then it gives you saying, it comes out the error on the screen or so saying we need paper. A completion of processing and interrupt. So on completion of processing and interrupt, state the steps that need to be taken before resuming the processing of the original job. On completion of state the steps that need to be taken before resuming. Check to see if sync to interrupt register. I don't know, is it going to be was repeating something from that happened before, where before an interrupt happens, so when an interrupt gets sent, it stores values, so it might check to see if data is within new registers or something. Let's have a look. Resets flags to inactive state, so of the interrupt it sets that to checks for further of course. So if you've got a list of or a queue of interrupts, then it would continue doing those other interrupts, and services them if necessary. Restore contents of registers from a stack, and that is the last step you do. So I'll probably try and remember the checks for future check for future interrupts and services them if necessary, then restore contents of registers. That's what I'll try and do. So it's 2 markers, so 2 points or so. Part of a personal computer operating system is a map of where files are stored on the hard disk even. Give the correct name for this feature and identify 3 items it stores. Correct name for this feature. Q is a map of where binary tree. Q. Turn to the list. So binary tree. Binary tree. Q. I'm thinking it might actually be a binary tree then. And then 3 items that it store. Oh no. A map, so it might be of where files are stored. I have no idea. Let's have a look. So the file allocation table. Oh wow. So then 3 items that it would store. I just seen it there. So on the additional guidance, it's got said like accept date, time, or last edited, links to further clusters. So that'd be any of the following. So maximum of 3. File names, file sizes, and free space. That's probably what I'll try and remember. So file allocation. So part of a PC operating system is a map of where files are stored on the hard disk. So the name for that is the file allocation table. Then the 3 items would be the file name, file size, and free space. But then again, you could also say extra ones, so it would be access rights and addresses. And it does say accept date or time or last edited, links to further clusters. I'll probably try and remember the main ones though. Ooh, 2A, here we go. An assembler may be used to produce machine code. State the type of language that an assembly language. Let's click on this. Should be assembly language. Yep, assembly language. Then describe machine code. So binary notation can only be, can be executed by the system. So binary notation or executable form, a set of all instructions available, bytes of data dependent on architecture. So those 4 points, but you've got to get 3 of them. So machine code is binary notation, which is a set of all instructions available. It is dependent on the architecture, of the system. Describe the steps of an assembler performs. Oh, steps. This question came up in 2010, I believe. State an assembler. Checks for errors. It also checks for errors. It can't think what else it does. Reserves space for storage and data. Replaces mnemonic opcodes by machine codes. Replaces symbolic addressing by numerical addressing. Creates symbol tables to match labels and addresses. Checks the syntax, so gives an error diagnostics, and that's it. I keep forgetting to sign out with Skype. Not Skype, Steam. Yeah, so let's see. So steps. So reserves storage for instructions and data. Is it like 1 mark per each then? I think it might be. So reserve spaces for instructions and data. I'll say replaces symbolic addressing by numerical addressing. And checks the syntax. And replaces mnemonics and mnemonic opcodes by machine codes. When producing a program, programmer may use library routines. Give 3 reasons why library routines are used. So this question was actually came up early it just said give. This was the paper before this, so the June 2011. It was actually a marker which involved library routines. So it was like explain how a library routine may help the programmer, and explain how the programmer would use it. So this is just given 3 reasons. So reason 1 would be that is error free. Error free. So it's already tested. That might be like on a different line, but I'm just going to say it on the same line. So it was error free. It is already tested, so that is error free. It can be in different languages, and it saves processor time. It saves time. Performs a common task. They are error free, so they have been tested. Ready to use. Saves saves work. Saves time. Maybe used multiple times. Maybe written in different source languages. Use other programmers' expertise. So I did actually get the 3 marks, yeah. So error free. So either say error free or has been tested. Oh, von Neumann. So von Neumann architecture, that is a single control unit, which it has a single control unit. What else? Well, this question came up earlier as well, so and I can't remember it from then. You can probably hear my fan in my background. Well, in the background. So we've got that it is a single control unit. Would they want limited, or just limited instruction set maybe? So a single control unit, 1 instruction at a time, uses the state that it uses the fetch decode execute cycle. Programs stored with data, programs and data in the same format. So 3 marks. So single control unit, 1 instruction at a time, uses the fetch decode execute cycle. Give the correct names of 2 other machine architectures. Other architectures. Is it going to be like the array processor maybe? Is that? Yeah, array processor and parallel processor. Oh, they also do accept the reduced instruction set and then the complex instruction set as well. So this is the other machine architecture, so that links into the types of processors, so the parallel, array and vector processing. Hadn't explained what that is, but just stick with the 2 main ones. So parallel and array processor. So they do say that you can do the reduced instruction set computing and then the complex instruction set computer as well, but I would probably just try to stick with the 2 main ones, since this is just more guidance. Describe the use of the memory data register, so MDR. It holds the data of the instruction. It then passes the data, or they might want you to say it gets the data from the address that was given to it by the memory address register, which was given to it which was from the PC. They might want you to do something like that. Let's have a look. So instruction from address is in MAR is copied to MDR, so I did say that a bit. Instruction is in MDR, so you've got to go, so it's like go back 1, then skip ahead 1. So try and work through the process. So the address from the MAR is copied to the MDR. So the data from the address in MAR is copied to the MDR. The instruction in the MDR is copied to the CIR. The MDR acts as a buffer or temporary storage. The MDR contains the data, so I did see that at the start. When being transferred between memory and processor. Explain the use of the accumulator. That's the add-in thing. It's the maths part, isn't it? Oh, holds data being processed. Processed is temporary storage of immediate results in the ALU. It is where calculations are performed, input outputs, data passes through. Right, so I need to make a note of accumulator so I can put it on my notes board. Right then, so the next thing, oh here we go, this is what I like. So here we go. Okay, where did I put my pen? Oh, there we go, it's on my bed. The real binary number may be represented in the normalized floating point binary notation. 3 bits for the mantissa, 5 bits for the exponent. So convert this number to denary. So if you have a look at the mat tab over here, so on the team viewer tab, this thing here. So let's see, so 3 bits for the mantissa, so it's going to be -1, a half, so we're converting it. Oh, good. This is lagging. And then it for the exponent, it goes 1, 2, 3, 4. Wait, it doesn't go 3, does it? Wow, I'm half asleep. Why is browser open? This is going extremely slow. Okay, that is lagging a bit. So 4, 8, and 16. So it's going to be -16. Well, this is lagging. That is actually lagging quite a bit. So 3 bits from mantissa, so let's fill this in, so 0, 1, 1. Oh, why is this lagging so much? This process isn't that. What is being done? Is there that maintenance being done or something? Nope. Where's camera on? Yeah, it's been so slow. I'll probably restart it after I've done this. Just like take a snapshot maybe of that. So there's the exponent, so it's going to be half plus a quarter, which is, there's my calculator, and I know some of you could probably do this in my head, in your head, but I am just lazy. And no one is actually watching the stream live, so it's 3 over 4, which is 0.5, so we need to times it by 2 to the value of the exponent, which is 4. So times 2 to 4, which gives you 12. Wow, that is lagging a lot. So let's have a look, see if this is correct. Exponent represents 4. Yep, I've showed you that. Mantissa is not, yeah, is 0, 1, 1. Moves to right place. Oh, it's normalized, isn't it? Value, yeah, value is 12. There we go. So that is one way you could have done it, where you do represents 4, then do it that way, where you move the exponent itself. But I prefer doing it my way, which is, well, the way that I've been taught, where you just do it like this. So 0.11 represents 3/4 or 0.75. The value of 3/4 then multiplied by 2 to the power of 4, which is 3/4 times 16. Oh yeah, they broke it down then, which is 12. Ooh. Right, so I'm actually going to quickly restart my tablet actually. Just restarting it. And don't worry, if you did see my the team viewer password to my computer, I've removed it anyway, so you couldn't. I've just changed it, so you don't know what it is. Right then, so yeah, so let's restart my tablet. So technical difficulties. Not sure why it's been so slow though. It might be because it's been on for quite a while then. So Windows 8 tab and it only has like 1 gig RAM. So it might just need. So it's been on for about 3 days or so, maybe, or just 2 days. I got hiccups. Right, let's just connect to Mat tab. Here we go, and we're back up. Right, and so the next one. There we go, that's a lot less lag now. So the next one, convert the denary number 1/8 to normalized floating point binary. Okay, so in the format described, so 3 bits from Mantissa. So first of all, we need to convert this. So 3 bits. Yeah, so we're gonna have the dot there. Ooh. So then half, quarter, eighth, and 16th, and it's gonna. Yeah, I'm just gonna do it like that. So it's gonna be 1, 2, 4. So see, it's 3 bits. So 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So this is just doing the step-by-step method. So, well, I'm just doing steps. I'm not really sure what exactly method this is, but still. So 1/8. So it's gonna be just those zeros there. So 0, 0. I know that looks like a 6, but that is a 0. 0, 0. Ooh, apparently my antivirus is not active. Dun dun dun. So 1/8. So now we've got to normalize it. Convert the denary number to a normalized floating point in the format. So we've just got to normalize this. So we've got to move the dot. So 1, and it's a 0.1. So it's the actual value of it is 1/8, which is 0.125. So it is above 1, so it's going to be, well, it's above 0, so it's positive numbers. So the exponent should actually be positive. Well, I think it is. Actually, it's going to be minus, isn't it? So since we're going backwards, so 1, 2. So then it gives us the 0, 1, 0, since it's going to be 3 bits for the manticore. So now we just got to work out the exponent. So there's 2 things. So it's going to go 1, 2, 4, 8. I mean, 5 bits for the, so minus 16. So this is, I believe this is actually minus, isn't it? Or is this positive? I think it actually is positive instead, actually. So it'll be 0, 0, 0, 1, 0. That should be it. If it isn't, then I need to redo some more of this stuff. So, because I'm second guessing myself. So here we go. Value is 0.1. Yeah. So, yeah, I did it wrong. So it is actually meant to be, so if you go this way, that is positive and that is negative. So it's going to have to be the 1, 1. So minus 16 plus 8, which would give you 8. Then plus 4 gives you 4, plus 2 gives you 2, and 0. So that is how you'll do it. So this represents minus 2. So I'm just going to go minus 2. Just say that there. Ooh, accidentally used the scroll wheel instead. And know what happens if I use the scroll wheel? It goes down to the next question. So answer is 0, 1, 0. Oh yeah, something you might want to do at the end though, once you've worked it out, is just go 0, 1. So if you say it at the end, and then if you circle it as well, so the examiner kind of, hopefully you can make life a bit easier for the examiner. Yeah, so it's 0.1 as the number is positive, but the exponent is negative. Yeah, exponent is negative 2 in 5 bits, so it's going to plus 2 is, you just pretty much invert it almost. You just do the 2's complement on it, except for you don't add 1. What's it? Accept some alternate working, but a method must be shown. Show correct with no working is max. So if you have the correct answer but you don't show your working, then it's 2 marks only for the manticore experiment. Well, manticore experiment normalized. Let's have a look at the next question. Oh, here we go, another one. Yay! More practice. Alternate representation is configured using normalized floating point binary notation. With 5 bits for the manticore, 3 bits for exponent, both into complementary. Just convert it. Okay, so minus 1, a half. Oh wow, I just wrote this in. Let's turn it back. Yeah, I need to do consistency stuff, so I'm just gonna undo. There we go, so minus 1, then it's going to be a half, then quarter, then eighth, then 16th, so 5 bits for the manticore, so 1, 2, 3, 4, 5, then the exponent is going to be minus 4, 2, 1, so exponent is, so this thing is actually it's going to be a negative number, and it's so 0, 0, 1, 1, 0, and this is already normalized, so we don't need to normalize it, but we've got to convert it. So 1 over 2 plus 1 over 4 gives us, I believe, 3 over 4, because I think that is from the previous one. Yep, I just checked on the calculator. It's been a while since I've done proper maths. So then we need to times it by 2. We need to times it by the exponent, which is minus 4. So then it would give us the answer. So I'm just going to go underneath equals. So times 2 to the power of minus 4, which gives us 3 over 64, which equals 0.046875. Now, you could probably actually leave it in the fraction, because it might accept it. Let's see. Here we go. So, there we go. There's one way of doing it, which gives you, yeah, so they don't, looks like that method, they don't mind if you leave it as a fraction, but then this method, they want you to answer it. Yeah, so this is the way I did, but they can allow you to leave the fraction, so you don't really need to convert it. Oops, daisy, I just showed you the next answer. Oh well. I'll show you how we'll get the answer, and there's no guidance as well. So let's go to the next one. So the following number is written in floating point binary notation. 6 bits for the mantissa, 6 bits for the exponent. Also, it's a 12-bit. In total, we've got to normalize it. Okay, so so go 1 2 4 0 0 0 0 0 0 8 16 32. So it's going to be minus 32. Then it's going to be 1 2 4 8 16 32 1 2 3 4 5 6. So then again 0 0 0 0 0 1. So this is given value 1 at the moment, but we need to normalize it, so the dot is actually here, and we've got to move it so it is 0 1. So we've got to move it 1 2 3 4. So it moves 4. So it's going to be 0 1 0 0 0 0. Then so that's the mantissa. And then this is going. Then I need to work out the exponent. So it's going to be 1 2 3 4. So it's going to be plus 4. So 0 0 0 1 0 0. Almost a mirror image, but not quite. That is what I believe it is. Yeah, so just you just got to normalize this. I don't think you actually need to find out what the value is. So let's have a look. So answer is what? Oh, because it goes minor. What? I thought the minus the dot goes between the first 2 bits. Yeah, in 6 bits, normalized mantissa is. How's it exponent that? Oh, it becomes minus 4 to the right. Oh, yeah. Because it moves, that becomes a minus, because it moves. So that way is minus, that way is positive. Oh, I forgot about that. So I've got the mantissa right, but not the exponent. I keep forgetting that if you go to the right is minus, go to the left is positive. Give the stages of a binary search for the word. So I'm actually going to update this actually. So it should be 1 1 1 1 0 0. Because yeah, it's actually minus 4. So give the stages of a binary search for, so search in whole. So you can listen searches, but you're going to have to use the examples. So you split the list in half. So if I just open up a new pad, so you have the list. So you have the list. You go to the center. Then you see if it's higher or lower. So you go to searching for whole. So and that is, so it has, so go splits the list in half. Displays the one of the middle values. So whole, it does whole, is whole, does whole. So is whole? Yes. So then it finds it. But if you go to Kenta, is whole less than Kenta? Yes. Well, Kentul. Yes. So then it divides the list in half, so then only that data is shown. And it says, then it halves it again, so is whole more than Chester? And you go, yes. So then it splits it again. And it says, is Epson whole? Yes or no? No. Then it would. So is Epson more than whole? No. So then it goes to whole. So then it splits it again, just so it's got whole left. So it's just saying, does whole equal whole? So it keeps splitting the list in half. So start at midpoint, which is Kendall. It's actually, yeah, it is a midpoint. What was I thinking whole and Kendall was? 1 2 3 4 5 6 7 8 9. I was thinking there was 8 then. So start at midpoint Kendall. Whole is less than Kendall, so take the first half of the list. So that's what I've done there. Then discard the rest of the list, so that this area here is discarded. But make sure you, this is just me like trying to explain it like this, but try and actually word it down instead. Whole is less than Kendall, rest of the list is discarded. Repeat halving until whole is found. So you just need to say repeat halving. Explain one advantage and one disadvantage of a binary search compared with a serial search. An advantage of a binary search is that multiple pieces of data is discarded at once. A disadvantage, so for an advantage would be binary search is quicker since it is quicker on larger lists since it discards a lot of data at once. A disadvantage is that the list needs to be in some sort of order. So I said, so it needs to be, so add is that it needs to, so what did I say? Binary search is quicker since discard data, so multiple pieces of data. Let's do data.
You've said mid-sentence like 20 times.
I'm streaming.
In the past 2 minutes. Hi guys. Hi.
Yeah. Right. So, and disadvantage would be this needs to be in order. So, means order. Let's see if that's correct. Advantage, so usually faster because fewer items are checked. Disadvantage is that it must be in order to allow appropriate items to be discarded. Oh, yeah, so we wanted to say one, then explain it more. Give the result of merging these data things, so you see that they are actually in an order, so you will need to put them in order, so it would be in alphabetical order as they are, so it would be add. So let's actually write it down. So it's going to be Adam, there we go, Adam, then it's going to be Ben, but only one Ben which is written down, because when you merge two data files and there's the same value, those are merged together, so there's only one value since there's no duplication. Then there's Charlie, then there is George, then it's Judy, then it's just going to be adding on the rest of data, so then Susie, then Yasmin. I know that, well, that looks like an 8, but it's meant to be an S. So let's have a look. So Adam, Ben, Charlie, George, Judy, Mike, Susie, and Yasmin. And as you notice, only one Ben. That is because there's no duplication. State 2 features of files that can be merged. So they need to have so 2 features. They need to be the same data type. So let's actually make a note of this. So same data type. This is what I'm saying. Data type. And maybe of files, same data. Well, I cannot even read that at all. Same data type and maybe order. Although you can do like serial search, which is just adding files onto each other. Let's have a look. Records have a common key. Each files each have records sorted into the same order, so common key and must be sorted into the same order. Describe a queue data structure. So a queue is, you probably say first in, first out. And quick response time, maybe, or no, because the person at the end queue, he doesn't have a quick response time, so be first in, first out. So uses of a queue. So 2 uses would be describe a queue data structure. So first in, last out, where the different priorities could be declared. So an interrupt maybe. So first in, first out. Data items are added at one end and removed at another. So first in, first out. 2 pointers are required, and the guidance is that, so diagrammatic answer. Oh, so you could have drawn a diagram. So you could allow 1 pointer with length q. So 2 pointers are required, which is the front pointer and the 3 pointer. She's playing the keyboard. State 2 uses state 2 uses of a queue in a computer system. When you're printing a file, maybe, and moving data from one place to another. So let's see. So spool queue. So job waits. Yeah. So print. Spooling queue and job waiting for printer, and jobs required. Job queue in a batch process in system. Handling of jobs in a round robin system. State what validation must be done before adding a new. Validation is to check. So when you're adding data, you need to check to see if the stack is already full. So check if queue before adding its queue. So check if queue is already full. It's not already full even. So check that. So the validation that must be done before adding data is check that queue is not already full. Then if you want to remove data from a queue, you have to check to see if the queue is not empty. Queue is not empty, yes. UML diagrams show what happens when a student prepares an essay. Choose topic, check self. So you have to name this type of UML diagram, and we did see that we always saw the answer, which is an activity diagram. So it's actually similar to a flowchart. Transition, what? Oh, that's that's the whole of A. Wow. So activity diagram is what the UML diagram is. So you see that there's the decision. So there's the decision which is there. And the arrows represent the transition. So from the start to topic, you choose a topic, then you check the bookshelf, then you go to a decision. So there is a relative book available, make notes, write essay, then finish. If there is no relevant book, visit a library, then borrow the books, then make notes. So transition. The term written in square brackets, that is an outcome to a decision, isn't it? Oh, conditional statements. A simple UML object diagram is shown below. There's an object diagram. Explain the purpose. Okay. The link between the library member and the librarian of an object diagram. So not exactly that one, but you might want to use examples from it. So the purpose is to show the relationship between different entities. Give information about instances of a class and how they link at specific times. Explain what must be added to an object diagram for it to become a communication diagram, and show one example on this diagram. communication, it'd be the arrows. You add arrows. Should add arrows. So you add so message or interaction from one object to another. Numbers on label may be omitted. On diagram, so draw an arrow. For example, you would just do that. And you have to give the appropriate name. So explain what burst me added. So you need to add a message from one object to another. Then you need to show one example on this diagram. That's when you draw the arrow with the appropriate label. So process author request, and then brackets name. Oh, we're halfway through, yay. Procedures. So procedures may be used to develop a program using stepwise refinement. Oh, so that's so the 3 benefits is that a large task can be broken into smaller and smaller smaller tasks. Easily shared between a team, and so share between team, and another so share between team, so large task can be broken down into smaller tasks. That looks like an F. Tasks. And then third one, I cannot stepwise maybe use of library routines. Let's have a look. So procedures tested separately, easier to maintain a program, main program is simpler, use of library routines to save time, code is reusable, programs produced faster, as processes may be shared between programmers. I may have got this, I may have only got like 2 marks maybe for this. Stepwise refinement is where a large task can be broken down into smaller and smaller subtasks, which are easier to manage. Problems broken down into sections, which become progressively smaller, until each section can be written as a single procedure. Right, so problem can be broken into sections, which become progressively smaller, until each section can be written as a single procedure. Some programming languages, some programming languages allow the use of global variables and local variables. So a global variable can be used throughout the system, and one example of its use would be so would they want it to be from the library, maybe? So global variable could be the name of the library itself, maybe, and then local variable would be, so is it defined within a routine, within a procedure. Just to quickly to the term global variable, so a variable defined at the start of the program exists throughout the program, including functions and procedures, allows data to be shared by modules, overwritten by local variables with same name, that way, so that's a global variable. maximum 3 unless an example is given. So an example is your last mark. The term local variable is declared within a procedure and exists within that procedure and can overwrite global variables with the same name. An example, the name of the book. A variable defined within one module, only accessible within that module. Data is lost when module is completed. Same variable name may be used in different modules. Can overwrite global variables, so I would have got that. Then a loop counter, that would be an example. Oh yeah, because you'll have the set an integer to 1, repeat until int equals 3 or so, and then once that equals 3, the integer gets like reset. So you could declare as a global variable, so integer equals 0, then in one of the classes you said repeat until so and so equals 1, and then it can do a task after that, so like something like that. A computer uses a number of registers. Explain why registers are used rather than the random access memory. Registers are closer, so you want to talk about is closer to the processor, so that it is quicker than random access memory. The registers can hold specific data types, so let's write it down. Let's write this down actually. So closer to processor is closer to the processor, and that it is specific data can be held, or data type. Data type will be specific data. Yeah, it's gonna do specific data can be held. And then so you want to do 3 things. So close to the program, you might want to give an example. So I'll say the memory data, so MDR. No, actually they might want an example, but they might not. Let's have a look. So let's see, what do they want? Faster to access, so faster, used for a specific purpose, so I got that bit there. Which involves frequent access. Oh, so just wanted that then. So faster to access. So just do faster. They didn't want to say closer to the processor, so just faster to access than random access memory. Used for a specific purpose, which involves frequent access. So it needs to be accessed repeatedly so it's quicker, and it is used for specific purpose since it involves frequent access. Describe the use and purpose of the program counter. Oh, is this when it's going to be like the PC gives the holds the address of instruction. PC gives address, so PC. Oh no, it's going to be like the CIR. The PC gives PC gives no, PC gives address to MDR. PC increments then MDR passes anyways MAR, isn't it? That holds the address, so MAR passes address to CIR or something like that, or does the PC gets the address from the CR. So that would be describe the use, and the purpose would be, I don't know, let's have a look. Contains the address of the next instruction, so holds the address of the next instruction, yeah, I got that point. During the execute cycle, except when an interrupt is being processed, address of IS insert service, yeah, so contents of PC is copied, so PC gives, so it would be copies, so contents of PCs are copied to MAR, so I may have got that. PC is incremented, I would have got that. For jump instruction, address from CIR, oh yeah, includes something about a jump instruction, of course. I keep saying of course, thinking that I'll remember it, but I won't. So 5 marks, and there are actually 5 points, so the use and purpose of a program counter is that it contains address of the next instruction to be executed during the effects execute cycle. The contents of the PC are copied to the MAR, then PC is incremented. For jump instruction, the address from CIR, so current instruction register, is put into the PC. 1, 2, 3. Yeah, just 3 questions left, yay. So in a college, a relationship database is used to store information about students and courses. Each student may study a number of courses. For example, Tom studies both Java programming and maths for computing. Each course has a number of students studying. Explain the relationship between the entities student and course. You may refer to normalization primary key, and you should include an entity. Okay then. Relationship between the student and course is that the student may have many courses. Oh no, not many students. Well, actually it could be, couldn't it? But then again, they probably don't want to, do they? And wait, is this actually an entity relationship? I don't think this is. Wait, yeah, this is an entity relationship diagram, isn't it? I was just thinking of something else. So that is the course. A primary key within student will probably be, so P key, pri key, I'm just going to call it. So pri key you could have given, so, oh wait, normalization, so that would be a many to many, wouldn't it? So it needs to be not in 3NF. So not in 3NF, it needs to be normalized. I'm not sure if they will actually want you to normalize it though, so in this, so a primary key would probably be the student, so stud ID, and then within, wow, I've spelled course wrong. There we go. So course, then course could be some secondary keys, which could be teacher ID maybe. So teach. yeah, so the course would be like the subject itself. So then it's going to have a subject. That might be its own entity within there. Teacher ID would might be its own primary key. Subject, that isn't really anything. So in the middle they would have. So in the middle they had student. It's going to call stud. Then it's going to be stud course, and then it's going to be so that's going to be a one to many, and that's going to be a many to one, which is course. So you have to explain what a foreign key is, and then give an example of what one might be. So for instance, so student ID might be one, but then also the name of the student, and a foreign key would also be, let's see, so right, so they did actually want you to draw a diagram as well. Okay, so points to be made about normalization. So relationship between student and course is many to many. So you can draw a diagram and then explain that there are many students that can take many courses. It is not many to many relationships are not allowed, so the system described is not in 3NF. Normalization resolves many to many relationship, and additional entry must be inserted between. So state why what needs to be inserted, then you can do an example. Let's have a look. Level response. Yeah, that's just nothing really. So it's going to be on the next page. So primary key. Student has a primary key, so student ID, which is uniquely identified of each student. Yeah, of course, he has a primary key. So course has a primary key, which is course ID, which is a unique key, and they would be stored within the student course. So which identifies each course. The foreign key would be student ID or course ID, as it acts as a foreign key to link the entities, so to provide a relationship between the linked entities, student and course. Student ID and course ID form a composite key, which is part of the primary key for the link entity. Oh, I need to get a drink. It's nearly over. It's only been going for about, let's have a look at the exact time it's been going for. It's been going for an hour 13 minutes, and I have just been doing my stream since I started a bit before, which is an hour 14. So, describe a database management system. I hate this one. So a database management system, database that allows the user, describe it, so it allows the user to get information that they want. So software that allows the user to get information that they want. Handles complex, so a software that so you just get a mark just for saying a software that handles the complexities of managing a database, may provide a user interface, may use SQL to communicate with other programs, provides different views of the data for different users. And that's it. So 4 marks, and yeah, so software that handles the complexity of managing data, may provide a user interface, provides different views of data for different users, so that'd be different permissions. 2 tasks, so this is the actual, no, actually it's not the final question, damn it. It's only a couple more questions. I thought, it's because they have a blank page. So 2 tasks would be that it gives the user the information that they want, prevents unauthorized access. It wants it to be like that. finds data, adds new data, updates data, maintains indexes, maintains enforces data integrity rules, manages access rights. Oh, it's this. So this is declarative, I believe. And section W, that is the facts. X is the wall. So let's have a look. So, see, I said it was a declarative, and then it is facts, and then it is the wall, then it is the goal. So look for the question mark. That's what I'm doing. Let's have a look. So Y, yep. In section Z, so this area, the solution type thing, give the correct technique for what should happen next, which is backtracking. Yep. Oh, yeah, once you give the next. Oh wait, yes. List the next 3 steps of the solution. So using the same notation. So from it should repeat steps 1 to 5. Let's have a look. Oh, steps. Oh, right. They want you to add it on onto the end. So step 7, attempt to solve seal. So attempt to solve seal. So it'll just be repeating those stuff. And then find P, which is splash. So so P equals. So finds P equals splash. So line 7 would be changing, just copying the top row, then set P equals splash. Anything else? No. That's it. Right then, so that's the end of it. Wow. This area did actually go quite quick. So that's 4 marks just for all of that. So this is a declarative language. The W, so that is the facts. This is the wall. So if seal A and fish equal B, so that's the wall. Then eats P, Q, and you've got to find out, so what does P and Q mean? So that's the goal. Alright, so that's the end of this. Tomorrow, I believe I'm going to do... let's have a look. Tomorrow I am actually going to try and do... what is it? June 2012 I will try and do tomorrow at 4 PM, then January 2013 at 7 PM. Thanks for watching this video.